Welcome back to the Mad Podcast. Today, my guest is Jordan Tigani, CEO of cloud analytics company MotherDuck. MotherDuck and the DuckDB open source project have become very buzzy in the world of data infrastructure, with the promise of delivering fast, efficient analytics without the complexity of traditional big data solutions. We talked about why big data is dead and the rise of small data.
If you have smaller amounts of data, you can move faster, less expensively, because the architecture is simpler. We can focus more on building better experiences.
The MotherDuck product and its focus on speed.
We can do queries in sort of single-digit milliseconds. In BigQuery, we were very, very happy when we got the overhead down to like 400 milliseconds.
And Jordan's unlikely entrepreneurial journey.
I always figured that there's people out there that are like going to start companies, and then there's like kind of normal people. And I was one of the normal people.
Please enjoy this great conversation with Jordan. It feels like the absolutely unescapable, unavoidable way to start this conversation is to talk about small data. Just when we thought we had finally made it in the world of big data, you came up with a very well written and very noticed blog post in early 2023 called Big Data is Dead. And like you built a whole thing around this, and just last week in San Francisco, you ran the Small Data Conference. So, small data, what is it all about?
So I'm very glad you said that it was unavoidable like that. I mean, we did a lot to try to get the message out and get people excited, and it feels like it's a little bit sort of counter the prevailing narrative that everything for 15 years has been about big data this, big data that, how big's your data, how much can you scale? And kind of the tipping point for me was when I saw the sort of Databricks versus Snowflake they had this benchmarking war, and everybody is focused on like the war between Databricks and Snowflake. And to me, the biggest thing that I noticed was like, wow, they're looking at the database benchmark at the query sizes they were using was 100 terabytes. And I remembered back from my time at BigQuery, we had some of the largest customers in the world. We had Walmart, Home Depot, Equifax, HSBC, and nobody was using anything, running queries anywhere near that, because it would have actually fallen over at the time. And so I knew that, and people were kind of not even really pushing up against limits. And so I thought wow, if this is sort of the state of the art, that people are focusing on this size of data that nobody has, there's got to be an opportunity actually to sort of look at the smaller data sizes. And I kind of was remembering back to when I was doing a bunch of analysis, also when I was at BigQuery, on the query sizes that people were using, and most people actually were had small data. The amount of data they were actually using was even smaller than that, and so kind of was like, hey, I bet if you were going to design a system these days from scratch, you do it differently. After Google came out with MapReduce and GFS and Bigtable, kind of everybody's.
All of which was in 2006, right?
Yeah,
so
2004
we're going on 20 years.
2006. Yeah. Everybody's brain just sort of broke, and they're like, wow, in order to build systems that can handle the data sizes that we're seeing, you have to just dramatically change how you're building them. You have to run on lots of machines, lots of cheap, inexpensive machines versus, these giant, hyper expensive machines. And to be fair, that was a problem at the time. But nowadays, I've got a Mac M2 laptop. It's 2 years old. It's probably an order of magnitude to 2 orders of magnitude faster than the server machines were back when MapReduce came out and people started building these systems. Let alone nowadays the server systems have hundreds of cores and can have terabytes of RAM. And so really kind of if you were going to build something now, why would you bother with all the complexity of scale out? Because the thing about the way we design systems, I was one of the people that helped start Google BigQuery, and I worked on single store for a couple of years. So I have been in with my elbows deep in building these complicated systems. Is that there's just this huge tax that you pay to have to build a distributed system that scales out and can do distributed transactions and shuffling data and if you were going to design something for kind of modern hardware, you could make it much, much faster. And you could make it much simpler. So meaning you could actually progress faster. Because that was one of the things is like, there was a couple of like well-known join optimizations that we added to BigQuery. And they took like a year to do. And they weren't that hard. It's just that to get everything right was, just took means that it took a long time. So sort of getting back to small data, kind of the idea is that if you have massive amounts of data, you have to build these complex systems. If you have smaller amounts of data, you actually don't need such complexity, and you can move faster, less expensively. And also now that networking speeds and local machines, laptops have gotten so much more performant, you can actually push workloads down to the end user, and that opens up so many kind of new and different architectures and different ways of handling data and building systems. And I think we're starting to see that with some other some startups out there that we invited to this small data conference. The conference was sort of born. It was the idea of Bob, the CEO of Weaviate, and he's like, "Hey, what do you think about like doing like a small data conference?" And I'm like, "That would be like that." I just love the idea because we try not to take ourselves too seriously at MotherDuck, and you sort of like, you kind of have big data London and, big data this and big data that, and that we could just sort of like kind of poke a little bit of fun at those things and do things a little bit differently. And
I was like looking at the, the manifesto that you have on the Small Data SF 2024 website, and I love. I mean, clearly you're having a lot of fun. Just from a marketing perspective, it's I have to give you kudos. It's amazingly well done. I mean, there's so many. It's so hard if you're a technical company to break through the noise and come up with something that feels like a movement and feels like a manifesto. And like you guys have done a remarkable job doing that, and it's really fun to watch.
Thanks so much. I think a couple times in my career, I have built things that I thought were amazing technology, and like didn't get the other pieces right, and nobody saw them, and so I think
distribution matters as it turns out, right?
Yeah, just kind of distribution, excitement, and so kind of when we started MotherDuck, it was sort of a very deliberately wanted to make sure that we weren't just sort of, writing a bunch of code and throwing it over the wall and saying, hey, if we build it, they will come. That we were also kind of trying to tie it to some thought leadership, take advantage of, we have several people in the company who kind of have a lot of experience building these kinds of systems and kind of had seen, kind of the trend going in this direction, and kind of where we thought the world should go was in this other direction. And so, had something we could be passionate about and that we could write about and, and add a little bit of fun and sense of humor to it. I guess always helps.
So a couple of just questions, which I'm sure you've gotten 1,000 times. If you already have, BigQuery in place, or Snowflake or Databricks, or like the whole like big data kind of infrastructure, modern data stack, whatever you call it. If you can do the big data stuff, can't you do the small data with it? I mean, isn't that shouldn't they be priced in a way that ultimately that should not make a difference to you?
Yeah, and so I think I mentioned kind of before that there's like this tax you pay with these complex distributed systems, and you pay the tax twice. You pay the tax in terms of latency. It's just if you think about it.
Latency is going to query the whole thing.
Well, you're going to query the whole thing, but also when you send a query to BigQuery, for example, like your query is going to get spread out over possibly 1,000 or thousands of machines. All of that coordination takes time. There's this scheduler allocating the slots. There's all the RPCs dealing with canceling things that had been running on them previously, getting all the results, aggregating the results. Like there's just a limit to how fast you can do that versus if it's just, the first machine that you hit actually runs the query. You can do things, we can do queries in sort of single-digit milliseconds. And, in BigQuery, we were very, very happy when we got kind of the overhead down to like 400 milliseconds. So that's like two orders of magnitude difference. And then on the other side, it's just the cost tax. You have to have all this hardware creates a lot of overhead. And, I think somebody that, a big bank did some benchmarking against BigQuery, Snowflake, and SingleStore when I was at SingleStore. And they estimated that on a per core basis, BigQuery was 40 times less efficient than SingleStore, which is kind of a more, dedicated performance optimized query engine. But so you're giving up at least an order of magnitude. And for Google, it's like whatever, we own the hardware, we'll just throw lots of cores at it. But at some point, you got to pay for those. Somebody's got to pay for those cores, and somebody's got to pay for that inefficiency. And so I think if you build these systems more simply, then you can have kind of dramatically less expensive. And then there's another bit that people don't always recognize, which is sort of the velocity of improvement. And often when you choose a technology, you want to stick with that technology for at least a few years. And so really what you're buying is not just where it is now, but where it's going to be a year from now, 2 years from now, 5 years from now. And when you kind of have these complex distributed systems, they get better very slowly. And if you look at DuckDB, for example, which is what my company is built on top of, like incredibly rapid pace of improvement, like incorporating like brand new stuff coming from algorithms, join order optimizations coming from academia. The graduate students that come up with those implement them in DuckDB, and then they ship them, and then they're out like a month later. And so I think that the kind of the rate of improvement is also something that you have to take into account. That kind of some of these big data systems are just going to have a hard time keeping up.
Is some of it a question of use case as well? Meaning, if you use data as in modern data stack for purposes of BI, effectively data analysis, then maybe small data makes a lot of sense. But if you want to, train a big machine learning model, then as abundantly documented, you want as much data as possible. Is there some truth to that?
Yeah, absolutely. There are clearly some use cases and some workloads that that are not small data. I think big data may be dead, but it's it's not going away. And I think the one thing that I often hear though is sometimes people are like, well, I read big data is dead, and I agreed with most of it, but I've got big data, but I think actually there's a lot of people that have a lot of data, but what they actually use is a small section of data. So you might have 10 years worth of logs. It might be a petabyte worth of logs. But if you only actually query the last 7 days or the last day, that's not really big data because of separation of storage and compute. That other data just sort of sits there and is cold on AWS S3, on object store somewhere. The important part is the part that you're querying, and the vast majority of workloads actually just query that hot data because it's expensive to query the whole thing. I mean, like I used to run this query. I used to give talks on BigQuery, and I'd get up on stage and I'd say, "Hey, look at this data set. It's a petabyte, and I'm going to query this whole petabyte." And I hit enter, and it would query the petabyte, and I would like, "Look, isn't that amazing? I queried a petabyte." And the thing that I didn't tell you is that cost $5,000 to query that petabyte. And I think big data has been able to make it possible to do some of these giant things, but if you still have to do all the work, you still have to do all the work, and they haven't been able to make that inexpensive. And so I think part of the kind of small data is actually sort of recognizing that, okay, in order to not have massively expensive analytics bills, you want to actually kind of slim down, aggregate, the work that you're doing. And often there's like people have the medallion architecture. You land data in the bronze tier, and then you kind of transform it a little bit into the silver tier. And then finally you have your gold presentation tier. Very often that presentation tier, that gold tier, is pretty small. And I think as you were mentioning, the stuff that you run your BI off of, if you have a human waiting there, you want that to be fast. And that's just kind of another reason to sort of use kind of a low latency, small data tool to operate on the gold tier data.
So I'd love to go into MotherDuck specifically. So what is DuckDB?
DuckDB, like SQLite, is just a library. It's something that, as you're building your code, you link that in. It's, functions that you can call inside that library, and you don't have to set up a separate server somewhere and call out to that server. It just sort of runs everything inside your process. And from a latency perspective, that's super nice. From a complexity perspective, it's also super nice. If you're running in Python, for example, the way Python works is kind of things in Python have access to the variable namespace. And so actually in DuckDB, you can query against your Python objects. So if you just link in, if you just import DuckDB actually in your Python process, you can just start querying data without even having to move it or prepare it or do anything. So it's just really, really kind of very high developer experience for accessing your data. It also works, well as a sort of standalone database as well. It's not just sort of in memory, but it's, I think it's, and it's also, because it's just a library, it has no dependencies, and it's incredibly lightweight. It can run in the browser, so it can run under WASM in the browser, so you can have a full blown query engine running in your browser. If you just go to shell.duckdb.org, it's like wow, I can run a bunch of SQL queries right in my browser without installing anything, which is sort of, I think, one of the things that makes it pretty unique.
And historically, that was a project developed at the university.
At a research institution in Amsterdam called CWI. It's also where Python was created. And
so who created it? Who are the creators of it?
So yeah, it was Hannes Mühlheisen and Mark Rosveld. Hannes was a professor. Mark was one of his graduate students, and Hannes had just gotten tenure, and so kind of nobody could tell him what to do for a little while. And Mark had finished his PhD papers early, and so nobody could really tell him what to do for a while. And they're like, "Hey, we've been using MonadDB, and kind of there's a bunch of limitations. Let's write our own." And to solve some problems that they'd seen in kind of the data science world, and that they're like, data scientists hate databases, and partly it's because they had to install databases and configure them and load data into them. And they said, "Hey, there's a better way." And it turns out that they're amazing. They're amazing database researchers, but also great engineers, and they were able to build a super useful system that just started becoming more and more popular.
And when was this? Roughly what year?
I think it was 2000. I think they've been going for 5 or 6 years. I think it's been 5.5 years now. So probably 2018.
Tell us about where MotherDuck fits in the puzzle.
I saw a tweet of somebody. I was still at Single Store, and it was doing somebody was doing some benchmarking of Single Store against BigQuery and Redshift and this thing that I'd never heard of called DuckDB. And I'm like, wow, that's really fast. Where did this come from? How is that possibly that fast? And I started digging into it, and I'm like, it's a research prototype. And then I realized, I actually kind of looked at it, and it's like, I saw their blog post on time zones. And in BigQuery, we didn't implement time zones for, I think, 6 or 7 years, because it's just really hard to get right. And there's all kinds of bizarro things in when you deal with with time zones. And we're like, well, we don't have to worry about that. Everybody can just convert from UTC, from Greenwich Mean Time. And the fact that they had actually had the attention to detail to do this, it was like, hey, there's something going on here, that this is not just a kind of something that you write to that you build to sort of do a couple of papers on to get your PhD. This is real. And so I'm like, somebody, like, it scales down so small. It's so lightweight. You could build an amazing serverless system using this, and somebody should put it in the cloud and and build a service around it. And I'm like, hey, I helped start BigQuery. I've done one of these before, and I helped with the single store SaaS service, and like I've done a couple of these. I kind of know how it works. Maybe that should be me. And I had never really thought of starting a company before, and but the idea, it just was so compelling, and the technology was amazing. And I met Hannes and Mark. I was actually on a.
So you just you just email them and say, hey.
Yeah, I got an intro from a mutual acquaintance. Acquaintance is actually Lloyd Tabb, the founder of Looker. And
in the world of like common acquaintances, that would be a good one. Yeah.
I knew that like DuckDB, he's working on Malloy, this metrics layer thing, and I knew that would work with DuckDB, and so I asked for an intro to those guys. He's also like, yeah, while you're at it, you should talk to my friend Tom. He invested in Looker. He'll give you some feedback on the idea. Tom was Tom Tungu's
who we did a great episode of the Mad podcast with, which will I guess we'll add this to the show notes, as real YouTubers say.
Yeah, and he did our seed for MotherDuck. And they're like, and at first I was asking for a job. I'm like, hey, what you guys are doing is really cool. I'd love to if you guys are going to build a cloud service, I'd love to come work.
Clearly,
with you
you're going to do that, right? Why wouldn't you do that? Yes. And they said no. They said, I know we don't want to do that.
And they said, no, we just really want to focus on kind of building the core database, and we're not really interested in that. But if you were going to do something like that, we'd love to partner with you. And that sort of got me thinking. And I was my first like vacation post COVID. I was in Portugal, and then I kind of rerouted the return. I went through Amsterdam instead of through Paris, and to meet Hannes and Mark. And we had scheduled like 4 hours in the afternoon. And I'm like, we're a bunch of nerds. Like, what are we going to talk about for 4 hours? Like, we're going to talk for like 45 minutes and be like, start getting nervous and awkward. But we just started like talking, and like we were just sort of geeking out about like this database and that database, and like next thing we know, it's like dinner time, and like kind of we went to dinner with like my wife was there, and Hannes's wife was there, and so kind of it was just like this really kind of cool meeting of the minds, and realized that we were that we could work together, I think, and and so that's how we kind of started working together, and I think what we did was I'm hoping that if this works out, and I'm obviously hoping that it works out, but that it will be kind of a model for how to do kind of an open source plus kind of corporate VC backed arrangement, because they have a foundation that kind of owns the DuckDB DuckDB IP. It's MIT license. It's always going to stay that. It's always going to stay kind of a open source. But we also gave them a chunk of the company when we started, like essentially a co-founder share. So, they're incentivized for us to be successful, but also we have no direct say on anything that they do. And so, like, Hannes may decide to go build something weird or something that we don't like, and that's just how it works. On the other hand, he did agree not to work with anybody who's doing something similar to what we're doing. But he's also incentivized not to do something kind of too off of the.
What about the community? I mean, I guess the community does what the community does, but it's sort of what's the word? Like a sort of a common wisdom in startup and venture circles that the commercial company building on top of the open source should also kind of own the community to the extent that any community can be owned. Like, how does that work for you guys?
Right now, we kind of have. They're somewhat disjoint communities. We have our MotherDuck community, and we have like a Slack, but also there's a pretty vibrant DuckDB community, in that we have not jumped in and tried to own or run anything. I don't think that would have gone over well. On the other hand, we try to be helpful where we can. We contribute a lot back to to DuckDB code, and we have great relationships with the founders and with the community, and so I think that's it's actually kind of a happy way of doing things. I mean, I think DuckDB is super popular, and we don't want to try to kind of horn in on that, as long as we can be successful by building our managed service.
And tell us about the company today. So I think you raised about $100 million across 3 rounds. Is that the right number?
Yeah, we raised our seed round from Redpoint and Madrona and Amplify. And then we got preempted a few months later, Andreessen, and then we got preempted for our B about 6 months later by Felicis. And building a database as a service is expensive. DuckDB is an amazing piece of software, but it's not a data warehouse. And kind of to turn that into a data warehouse, is hard. There's a lot of things that kind of like you poke it the wrong direction, it'll fall over. And then it's sort of like, well, nobody's ever poked it in that direction before. And so, it's just stuff to work through, stuff that, have to build. And we're building this, I think, pretty rich database as a service, and the serverless backend, this highly multi-tenant, this hybrid execution system, or actually dual execution system, where we can push workloads down to the end user and kind of split query plans. And so I think we're doing some interesting non-trivial stuff, partly because, you've seen, there's a model that I think I've seen before, which is in open source, where, somebody builds this great open source project, and then, that's what they completely focus on, because that's, to get adoption, to get excitement, to get funding, they have to build a great open source project. And then they say, well, we'll monetize with SaaS, and we'll put it in the cloud. And it's an afterthought. They have a couple of junior engineers work on it. And so it's just, you're basically just running the thing in a Kubernetes container. And it ends up being something that's kind of trivially clonable by, AWS, or, Google or somebody else. And you'd end up without actually much of a moat. And to me, actually, that's it's disappointing, not because the hard work gets cloned elsewhere, but it's disappointing because I think that there's a lot of things you can do, a lot of interesting architectures that you can build if you really focus on the SaaS service. And so for us, for MotherDuck, we are focusing on building this kind of, I think, unique way of delivering the service to users. And then DuckDB Labs gets to focus on building this great, amazing database. And, because our API is not a typical sort of like web API. You send a query and get a result back. Our API is like this partial query plan API, where you send a piece of a query plan and you get, a piece of a query plan back. And it's complex, but it's complex because it can actually deliver value. It can deliver value in that, you can join, data from your Postgres server against data that's living in the cloud. You can build, UIs that lets you query data and, at 60 frames per second and fly through your data as if it's a video game. And the reason that we can do that is because we can do part of the work locally and we can do part of the work in the cloud. So a long-winded answer, but, we are trying to, spend a lot of our innovation tokens on kind of how basically the SaaS infrastructure delivers a service to users.
You mentioned that, as we were saying right before we started recording, that you have 4 offices: Seattle, New York, Amsterdam, and SF.
Yes. So yeah, we have about 50 employees. We kind of started during COVID, and everybody was kind of explicitly remote. But I think, like a lot of people, we recognize that there's value to actually having people in person and collaborating and just sort of being able to feel like you're part of a real team. And so we realized almost everybody was in one of these 4 cities, Seattle, I'm in Seattle. That's where our headquarters is. San Francisco is just huge concentration of talent. New York, a couple of co-founders were there. Plus, it's sort of a nice balance between the West Coast and Europe. And then finally Amsterdam, because we wanted to be close to the DuckDB team, and so that we can kind of go over and poke and say how's that coming, or like take them to dinner, or just
could you do this faster?
help us actively manage the relationship. It's actually we're pretty evenly distributed so far, and I think it's working. I think it's working pretty well. Like each office is kind of developing its own flavor. Our New York office is probably the youngest office and the most fun.
Of course, New York.
The Amsterdam is the most academic, and and we have we raised $100 million, and we have several thousand users. It's growing super fast. We're sort of deliberately pricing it pretty low to to just we want you to be able to get in and get a data warehouse that works for $25 a month, and enterprise prices will of course end up being more than that, but we think you shouldn't have to spend thousands of dollars a month to do basic data warehousing and analytics.
And do you want to explain then what in memory means?
So transactional database, you're typically, you are operating on sort of one thing at a time. You have an order, and you create an order, and maybe you update the state of that order, and there's a bunch of like consistency checks to make sure that order matches a real customer and matches a real product and line items, et cetera. Analytical databases, on the other hand, tend to operate across data. So you can ask questions like, well, how many orders did I have in the last week, or how many orders broke? Who is my biggest customer by amount of data, amount that they spend, and then broken out by region, and those types of questions. The data tends to be stored differently in these types of databases. Column store versus row store, and and then there's also a subclass of databases which is sort of an in-memory database, which means that if you turn your computer off, you lose all the data. But on the other hand, memory is 4 orders of magnitude faster than disks, depending on what kind of disks, but it's generally much faster, and so you can do things blindingly fast. And I think there was a wave of in-memory databases that started about 10-15 years ago. MemSQL, which became single store, and which is where I worked previously. But I think it turns out that people really want they want persistence. They want if they take all the energy to load this data into their database, they want it to be there, and they want it to be transactionally updated, et cetera.
What makes DuckDB and MotherDuck then so fast and so appropriate for those use cases?
One of the things that makes it fast is it's a brand new database built from scratch, kind of applying kind of the latest and greatest best practices. There was a paper that Michael Stonebreaker wrote. I think about 50. Michael Stonebreaker is a Turing Award winner, like the Nobel Prize of Computer Science, in databases
and creator of many database companies.
Yeah, he created Postgres and Ingress. And I think the paper was called "No Free Lunch," and it was really about that. Like, hey, the technology has changed dramatically. Why haven't databases changed? Like the way, if you just think about SSDs, like you might have in your laptop, they don't have the spinning platter anymore. They're because of that, they're much faster to find things. There's some things that they do that are better, that are dramatically better. There's some things they do that aren't as good. But if you were going to build a new system, you would just build it differently. And but people ended up like, well, the old one works kind of well, and a decade. It's a decade or even more since that paper. More has changed than hardware in sizes and speeds. Like you get these, what are they called? Almost memory speed disks, and they totally upend the way people tend to think about the trade-offs in software. Like, it used to be, if you had to hit disk, it was like all of a sudden your program just screamed to a halt. And nowadays it's not so bad. You can amortize the costs of disk access. So kind of modern DuckDB, built with modern techniques, built really well, simply scale up by some really brilliant people, and made it very fast. And I think one of the other things they did is they avoided traps that kind of prematurely optimized. So one of the things people talk about for analytical databases is vectorized execution, which is not to be confused with vector databases. Those are actually something different. But in vectorized execution, you basically take a whole bunch of a vector of inputs, and you can process them all at once. And this is very nice for how computers use caches. It turns out to be sort of very efficient to write the code for those. But typically what people do is they get so excited about it, is that they're like, okay, I'm going to write special machine instructions that do this and do this fast. And we did this in BigQuery, and ClickHouse does it. A lot of these engines build these like hand-coded vectorized execution engines because there are computer instructions that are specifically deal with lots of things at once. But DuckDB wrote it in such a way that they let the compiler do that optimization for them, and they probably leave a little bit of performance on the table. But on the other hand, it just means that you don't have to maintain all this like crufty, really complex, nasty, hairy assembly code. You just have like these sort of kind of careful, elegantly written operators. And it also meant that, for example, when the Mac Silicon came out, it took them like 2 hours to make it work on the new Mac Silicon, versus like having to sort of do all this like complex hand coding stuff. So there's a bunch of reasons why DuckDB is fast. MotherDuck is fast because we sort of let DuckDB do its thing. We also we always have a DuckDB running on your client. So that could be in the web browser. There's a DuckDB running in your web browser, as well as on the server. Or if you're running in a Python process, or you're running, you're writing some code that connects to MotherDuck. There's a DuckDB inside that process, and that DuckDB, we can basically cache data there, and so queries that can hit that cache don't even have to hit the server at all. So if you think about, we have sort of some UI apps that we've built that will start out, and they'll have to run queries against the server, but then they'll end up sort of building this cache. And then so as you navigate the UI, everything happens locally. And so this is how you get the 60 frame per second kinds of visualization speeds that are literally impossible in more traditional architecture, because if I'm talking to a data center that is on the other side of the country, that's 100 milliseconds. And so the best I could possibly do, even if it was infinitely fast to do the query, would be 10 frames per second. And so you just you end up being sort of limited by the cloud architecture, but by pushing stuff down to the client, the only limits are the limits of the local execution speed, and the local execution speed is just much faster than it used to be. And getting faster, and the other thing is like more and more people have like fiber to the home or fiber to the workplace, and so kind of the pulling some of these data sets down, which used to be prohibitive, now it's like you can do in seconds or less.
Maybe to close on product, what is MotherDuck and DuckDB not good at yet, and that you have on the roadmap?
So, I mean, scale is certainly one limitation. And I think, if you're going to push past working sets of like 10 terabytes or larger, then, I think then MotherDuck doesn't work well yet. We're working on kind of, working with larger machine sizes and just sort of things that are going to scale better as you get bigger. But that's certainly something that can come up.
You mentioned vector databases, so that's another inevitable question about where MotherDuck fits in the nascent AI infrastructure stack. I saw on the website for small data SF that you were talking about small data, but also small models. Maybe walk us through that.
As we're pushing, I think there's a real analog to pushing data workloads down to the client, and then also being able to push models down to the client. And I think everybody who's worked on AI things has probably been sort of frustrated. You type something in, and in ChatGPT, and you kind of sit and you wait and you twiddle your thumbs and you wait and and yes, it's incredibly powerful, and you get these magical responses back, and they make it feel like it's faster by streaming results back, but it's actually quite slow. But if you can do a lot of the work, or certain types of questions or certain pieces of questions via a local model, then you can get kind of much more interactive AI applications, and especially if you're doing RAG or something where the retrieval augmented generation, where you're pulling data from somewhere. You're using basically a database to store state, and then you're using an LLM to kind of understand something about the world. Now, if you do it that way, you can actually use smaller models, because they don't have to quite understand. They don't have to encode all the state as well, and so you can do local RAG, where you're basically kind of doing local lookups and local inference, and then perhaps for the harder things, you can call out to the server, or you can start with an answer and then refine the answer from something that is remote. But I see there is some really nice parallels between kind of the architectural stuff that we're doing in MotherDuck, and things like Olama, where you can actually operate on models locally. And there's certainly really interesting things coming out with hardware and with compute environments that kind of lets you get access to the GPU and kind of do more AI stuff on your local client.
I saw that you seem to be good friends and partners with George at Fivetran. And I would have assumed that small data is not a good thing for the Fivetrans of the world, not to pick on them, but any company in that stack, because don't you need a lot of data and a lot of complexity for this modern data stack, this suite of vendors to thrive?
I mean, it's interesting you mentioned George and Fivetran, because he was a speaker at our Small Data SF conference. He and I did a town hall conversation, and one of the things that he said was it's shocking how little data people use, and generally, if people are pushing a lot of data through Fivetran, it's because they're doing something really inefficient, where they're basically just sort of they're recopying all their data every day. But typically, the sizes of data that they see are much smaller than people would expect. But I do think that the modern data stack, the ideas behind the modern data stack are important, and I think really that you have, you kind of have I would call it sort of 3, maybe 4 pieces. You have the data ingestion, you have kind of your query engine, and then you have your visualization layer. And then maybe the 4th would be kind of the orchestrator. And that would be sort of DBT. So Fivetran would be ingestion, Snowflake would be the query engine, Looker, the
visualization layer,
and then DBT, the orchestration. Obviously you can swap out those pieces, and there's lots of competitors in those spaces. I think kind of the world is still arranged in those buckets, and so I think kind of that is still valid. Like MotherDuck, I think we're playing in the we have a great query engine space, and you can hook us up to your BI tool, and We connect to, Tableau and Power BI and Omni and Preset, et cetera. And then you can hook us up to your, ingestion engine, whether it's Fivetran or Airbyte, et cetera. And it works great in DBT. And so we're playing well in the ecosystem. Does that, fast forward 5 years from now, does all that still look the same? Does, the advent of things like these open data formats, does that start to kind of change, how some of that work gets done?
Does it impact you at all, like in a world where Tabular and that was post the acquisition of Tabular by Databricks and the rise precisely of those open data format? Does that change anything for you?
It does sort of open up some doors for us. If you think about, a lot of people and we're hearing from a lot of people that, that are using Snowflake and they're moving their data into usually Iceberg as part of as a cost reduction, way to avoid lock-in, way to be more flexible and have more flexible access to their data. And that's great news for us, because if the data is locked in Snowflake and we want somebody to try MotherDuck, we have to convince them to export the data or write it to two places, have multiple copies, and it's a mess. It's a migration. If the data is in Iceberg, we have the same access to it that Snowflake does, and so I think that's going to be hard for the incumbents, and I think it's going to be a net benefit to the kind of the people that are coming in with new tools and new ways of doing things, and it's going to put pressure on margins, which again is also tends to be in favor of people that are coming in afterwards, especially if they have a simpler architecture and can deliver things, less expensively.
There is batch processing, which has its one stack. There is real-time processing, which has a different stack. And then there was big data and now the small data. And sort of what do I do? It feels like things are getting more complex rather than less. But it's part of the small data message that things are actually getting simpler, but you sort of need to get rid of some of the pieces of the past.
I think one of the things with small data is, I think because the architecture is simpler, we can focus more on building better experiences. So maybe there might be a plurality of tools involved or a plethora of tools involved. If those tools are simpler to use, then I think kind of the net cognitive load can go down. And I'll give an example is a lot of data is in CSV files. And as much as sort of as a database person, it sort of makes your head explode. You're like, why would you put all this in a CSV file? That's the way the world works, and it's simple and it's easy to write a CSV parser, and it's easy to write CSV. But there's so much broken CSV out there because it's actually really hard to write a totally unambiguous, correct CSV file, and everybody sort of does it differently. Different null characters, and is two empty quotes, is that a null or is that just an empty string? There's just all sorts of weird things that happen. And one of the things that DuckDB did is they said, okay, we're gonna really, really solve this problem, and we're gonna make it so that you can just do select star from CSV file name, and it will do the right thing. And they wrote a research paper on it. They put a full-time kind of PhD on it, and it keeps getting better. And they're writing more research papers on this. Versus if you look at other database companies, when I was at BigQuery, we put a college new grad on the CSV, and they worked on it for 3 months, and we're like, great, you shipped it, go work on something else, and so there's all sorts of corner cases or things don't work, and then we basically say, that's not our problem. Our problem is once you get into the database, it's your problem to go fix your CSV or and if you just think of it from the perspective of somebody who is trying to get work done, how much time do you spend wrangling broken CSV files. It's like, oh, this isn't working, and like, and and then so DuckDB can often make that just sort of magical and just sort of like, oh, it just works. I don't have to think about it. And that's like a small example, but it's a way that, yes, the number of tools are, maybe increasing, but hopefully, we can still make life simpler.
So to close, I'd love to go in a completely different direction and talk about your entrepreneurial experience. So you mentioned you hadn't started a company before, and you were most recently Chief Product Officer at the single store. What was the transition for like any technical person out there that may be thinking about starting their company? What was surprising in a bad way, but also in a good way?
I always figured that there's people out there that are like going to start companies, and then there's like kind of normal people. And I was one of the normal people, and never kind of, sold computers out of my dorm room, or like had, lawn mowing businesses, employing siblings. But I just sort of fell into this. And I think one of the lessons is like, you might not think that you're, an entrepreneur, but you too can do it. I think there's been a number of kind of surprises along the way, but I think one of them is that there's no one right way to do it. I kept expecting there's somebody who was like brilliant, Lloyd, for example, to be able to tell me the answers. Like, how should I think about this? How should I do this? How much money should I raise? Who should I raise from? How should I hire my first, engineers or my first salesperson? And you can listen to people who have been really successful. And that's one of the things that I love, is that founders tend to be so giving with their time to other founders, because otherwise I don't think I could have, kind of figured anything out, because I had literally no idea what I was doing when I got started. But you listen to them and you're like, okay, well, this person did X and is telling me you got to do exactly what I did, of course. And then another person who's equally successful does exactly the opposite. And you're like, wait, well, how can these two things be? And it's like, you realize that, well, this was the right thing for that person, and this was the right thing for this other person. I got to figure out what's right for my company and what's right for MotherDuck. It's so that it puts more pressure on your shoulders, but it's also like, it makes you realize that there's not one way. And I think one of the things that has been suggested is you got to rely on your intuition and what feels right and what seems right to your company. I think an example, from the early stages was, I asked one founder, like, well, how much should I raise? And he said, raise as little as possible, because you can always raise more. If you raise from somebody good, they're not going to let you run out of money. And then I raised from somebody else I asked for somebody else, and they said, raise as much as you can, because the only time you're ever at risk as a founder is when you're running out of money. If you control the board and you have plenty of money, you don't have to listen to anybody else. And both of those people are right.
Mm-hmm.
Like maybe more so and maybe less. I mean, like if you raise too much money, there's certainly, problems you can get into. If you raise too little money, like there's, certainly problems you can get into. And I think people, this was in 2022, kind of the tail end of the ZERP era. And then people started finding, well, maybe you can't always just hold your hand out and get more. So there were negatives on, positive and negatives on both sides. And you just got to figure out, okay, what's my decision framework and what works for me and what works for my company.
What about the commercial side of things, coming from a very technical background? How did you learn there? What was surprising? Again, was the a caveat mentioned up front that you seem to be doing an extraordinary job at marketing and marketing positioning.
So I was an engineer for 20 years, and I kind of bounced back and forth between engineer and engineering manager. And I worked on a couple of projects that I thought were beautiful. I thought were like, wow, I'm just so proud of this, and that like are dead, and they just because like the commercial value wasn't there. The company killed it, or the company's no longer there. And so I think one thing that the lesson that taught me was like, you've got to understand customers, you got to understand the market. And so I was part of the team that helped start Google BigQuery. And at one point I ended up moving into product. And part of the reason that I did that is because, first of all, I was being asked to help hire the director of product for BigQuery. And I kept interviewing people. I'm like, wow, this person just really doesn't get what's special about BigQuery, and like this would be terrible if that person was led the product. And then I thought, well, maybe I could do it, which felt like totally weird to go from engineering to product. But that just opened my eyes in so many different ways, because as in engineering, you're designing with this sort of palette. You have these things that you can do, these data structures that you can move, these systems that you're building that connect in certain ways. On the product side, you have sort of the same ideas. You have, customers and pricing and packaging and, your marketing team and your go-to-market and all these things. You have to sort of design something coherent. And if you don't make it coherent, and if you don't make it work, it doesn't work. Now, you don't get the same like positive feedback every day that you do when you kind of submit code and it works and you see it running. On the other hand, like, I think you can build something more real and more enduring if you kind of do take a product focus. So being a product manager for BigQuery did give me kind of exposure to some of these other parts of the world that I don't think I would have had. And then I jumped into the deep end at Single Store as the chief product officer. And, I was, as being in the C-suite, got to be, part of a lot of these discussions with the CRO and the CMO and the CEO and the CFO, and kind of like hearing how they were thinking about, fundraising and, sales comp plans and kind of marketing. And it's one of the, I realized that marketing is war. When you're at Google, you think, oh, well, you don't need to do marketing. Who needs to do marketing? But then you realize outside of Google is like, well, nobody cares about what you're doing. And you have to basically win over their eyeballs. You have to convince them to care, and you have to give them a good reason to do so. So I think it was a really good introduction to kind of what it takes to sort of to see what a successful startup company, much later stage startup company. I mean, they were 100 million in ARR. What that looks like and all the pieces, and then you can sort of extrapolate back down to, okay, it does feel like a whole different thing when you're just starting a company and it's just you and a couple of people, and like you don't even have a GitHub repository, and but like over time you can start to see, okay, well, this is like kind of the lineage that will get you to this thing kind of towards the end, which then, you look at then actually successful public companies, and, you see, okay, this is what gets you there. So that was a great, I highly recommend, being part of a, big tech company, because you learn how to do things right. But then I think also I recommend being part of a startup, because you learn how to get things done quickly, and you also get exposure to sort of much more pieces of the puzzle than you would otherwise.
Thank you so much for sharing the story and some lessons. Really appreciate you being here today.
Thanks. Appreciated the conversation.
Hi, it's Matt Turck again. Thanks for listening to this episode of the Mad Podcast. If you enjoyed it, we'd be very grateful if you would consider subscribing if you haven't already, or leaving a positive review or comment on whichever platform you're watching this or listening to this episode from. This really helps us build a podcast and get great guests. Thanks, and see you at the next episode.